Hi. So in the previous video, we were doing polynomial division, right? And we learned the synthetic division method. Okay. And notice that we obtained the remainder as the last term in the division process, right? At the right end, the last number that you get, in the lower row is your remainder, -1 in this case. And in the previous problem, our remainder was 0. Okay. But sometimes you just want to know the remainder, let's say. Okay, you don't want to know what the quotient is, you only wanted to get the remainder. And there is a theorem for that. Remainder theorem basically tells you what the remainder will be without knowing the quotient. Okay, without doing the division. If you divide this polynomial by this binomial x minus k, this will be your remainder. Okay, what is the remainder? P of k. That means basically if you plug in k in the polynomial, whatever you get is the remainder. Okay. So here is an example. Your polynomial p of x is x to the 4 plus 2x square minus 10 and k equals root 3, which means basically we are dividing this polynomial divided by x minus root 3. Okay. Suppose you divide that polynomial by x minus root 3, then what would be the remainder? That is the question. And the answer is the remainder will be p of root 3. And notice the change in sign. Okay, if you are dividing by x minus k, then the remainder is p of k. Okay, the opposite sign. So here, plug in that. Root 3 to the power 4 plus 2 times root 3 squared minus 10. Now root 3 square is 3. So that is going to be 3 square. Square plus 2 times 3 minus 10. So 9 plus 6 minus 10, which is 15 minus 10, 5. Okay. And can we verify it? Let us do it. Use synthetic division on this polynomial with that x minus root 3 as the factor and verify that your answer is matching. Okay. It will be a fun exercise because there is root 3. So you will have interesting time doing all that division. Algebra. Okay. You are dividing by x minus root 3. So root 3 goes here. The coefficients are 1, 0, 2, 0, minus 10. Make sure you understand those coefficients there. Okay, I discussed that in the previous video in detail. Okay, now let us drop the numbers. 1 goes down as it is. 1, then 1 times root 3, 0 plus root 3. Root 3 times root 3 is 3. 2 plus 3, 5. Okay. 5 times root 3 is 5 root 3. 0 plus 5 root 3 is 5 root 3. And if you multiply root 3 with 5 root 3, then root 3 times root 3 is 3. So 5 times 3, 15. And if you add them up, you get remainder 5. Okay, which is what we also got already. Okay. Now, this remainder theorem leads to a very interesting result. Okay. Think you're doing this division and at the end, the remainder is 0. suppose, okay, in any such division, what would be the implication of that? If you go up here, let's say, hypothetically, okay, I'm not saying that happened here. Hypothetically, if this part was 0, if the remainder was, instead of 1, if the remainder was 0, that is basically minus 0 at the end. So let's say we don't write it. Or here, if that instead of remainder being minus 1, if the remainder was 0, then you would have written that left side polynomial as x plus 1 times the quotient without any remainder. That means that x plus 1 is a factor. Like you basically factored it. If the remainder is 0, what we're getting here is a factorization, right? And actually, we already saw that in this problem. Remember earlier when we did this problem here at the bottom, I could have rewritten it. I wrote it as a division here, but at this point, let's say we write it as a product. So 2x squared plus 9x plus 4 will be equal to x plus 4 times that, right? X cube plus 2x plus 1, 0x squared. So I dropped it, okay? Plus the remainder is 0. So I didn't have to write it. And if you don't write it, it shows that x plus 4 is a factor. The left side polynomial is factored as x plus 4 times the quotient. Okay? So when the remainder is 0, the divisor is a factor of the polynomial. And that simple observation is called the factor theorem. The polynomial x minus k is a factor and k is a 0, by the way. If x minus k is a factor, then k is a 0. If it is a factor, then if you set it equal to 0, you will get x minus k equal to 0, and you get x equal to k as a 0 of the polynomial. If and only if p of k is 0. Why? Because p of k is the remainder by the remainder theorem. By remainder theorem, p of k is the remainder, and if the remainder is 0, then x minus k is a factor. Okay, so this is the factor theorem. All right. And since we know how to find that remainder by using synthetic division, now we have a very powerful tool. Okay. So given a polynomial and given a factor like x minus 1, x plus 1, x minus 2, x plus 2, I can immediately determine whether that x minus 1 or x minus 2 or x plus 3, if it is a factor of the polynomial or not, I can immediately determine by doing the synthetic division. At the end of the synthetic division, if the remainder is 0, then it is a factor, otherwise not. Okay. So let us look at an example here. Use synthetic division to determine whether the given number is a 0 of the polynomial. Okay. Which means x plus 1 is a factor or not. That is the question. Okay. And you know how to do the synthetic division very well. Please go ahead and do it and check with me. Minus 1 times 1 will be minus 1, comes down 3. Minus 1 times 3 will be minus 3. You get minus 8 here, which is not 0. So conclusion is minus 1 is not a 0 of p of x. Okay. Similarly, go ahead and do the next problem and then check your answer. Coefficient cube square x, and remember there has to be a constant term. If the constant term is missing, then that's 0. Okay. 9 is dropped here. 4 times minus 9 minus 36. Get 3. 3 times minus 4 12. You get 0. Minus 4 times 0 0. 0. Remainder is 0. So the answer is yes. Okay, minus 4 is a 0 of that polynomial p of x. Okay, we will move on to the next page. Find other zeros given 1. Okay, now that means you are already given there is a 0 3. Now we know what that means, right? If 3 is a 0, based on the factor theorem that we did just now, when you divide that polynomial, when you do the synthetic division, at the end the result should be 0, and we can factor it. 3 is a 0, so 1, 2, minus 11, minus 12. 1 is dropped here. 3 times 1, 3. 2 plus 3, 5. 3 times 5, 15. Minus 11 plus 15 is 4. 3 times 4 is 12. Minus 12 plus 12, 0. Of course, we need to have 0 there, otherwise 3 will not be a 0 of the polynomial. But not only that, we have more now. Therefore, I can now say my p of x, the polynomial, is x minus 3. If 3 is a 0, that x minus 3 is a factor there. Okay. Times the quotient is x square plus 5x plus 4. Always remember to start with 1 degree less. The polynomial is cubed, so the quotient here starts with x square. Okay, x square plus 5x plus 4. Now the question was find other zeros, right? The other zeros are here. Okay. Consider now x square plus 5x plus 4 equal to 0. Now how to solve that? That is a quadratic equation. So you solve either by factoring or by using the formula or by using the vertex form. We have studied 3 methods, right, of solving them. I can see a factoring works here, so I'm going to go with factoring. You can do it by other methods if you prefer. Five x plus 4, so it is x plus 1 and x plus 4. That gives you x equals minus 1 and minus 4 as your other two zeros. Okay. One more problem to practice. I keep saying again and again, pause the video, solve it. If you want to, if you are stuck, go back to the video, watch again, because it is just the same type, one more, Only after you have like done all that you can do, then you have to look at my solution. Four is there, coefficient, and it's minus 1, 4, 7, minus 28. And you get the -1 down, multiply, you get -4, that is 0, that becomes 0, you get 7 here, 4 times 7 is 28, and your result is 0. Okay, so that means, therefore, I can say my polynomial p of x is x minus 4 times minus x squared plus 7. Okay, now again, be careful. It is not plus 7x. It is just plus 7 because x term was the 0, has coefficient 0 in the quotient. Okay, minus 107. So that is because the polynomial is cube. This starts with x square, then x, then constant. So it is just 7. Okay, so you consider the remaining term minus x square plus 7 equal to 0. Now that of course means x square equals 7. Okay, take the 7 to the other side, becomes minus 7, and both are minus, left and right, cancel the minus, you get x square equals 7. And that means x is plus and minus of root 7. Okay. Okay. Factor it. More of the same exercise. Now this is actually less work. Okay. You don't even have to solve the equation, just factor it. Okay. Or may not be less work, maybe equal amount of work, because if you have to factor it, then you are almost there, you know. Like after you factor, you can anyway write the solution in one line. You can write the zeros in one line. Okay, go ahead and do it the same work again. It's more opportunity for you to practice. You should practice so many problems that, you know, it becomes a routine habit to, like, you know, write these coefficients, write it on the left side, and everything, you know, your speed should increase. Okay, 2 there, -1, -1, -6, -6 there, 0 there. Okay, and now I'll say therefore my polynomial p of x is x minus 1, 2x squared minus x minus 6. Okay. Now, I don't know how many of you know, remember this step of fact, like in factoring. I know most students know the technique, but when there is a coefficient other than 2, then you have to, other than 1, you have to multiply. Okay. So the 2 and 12, you have to multiply. The product is 12. So you have to think of numbers. When you multiply, you get 12, and the difference is 1. Okay. So here I would say product is 12 and difference is 1. Why do I look for difference? Because the last term is negative, right? -6. So whenever the constant number is negative, you have to look for difference. Difference equal to the middle coefficient. The coefficient of x is 1 here, -1x. So the difference has to be 1. Think of the numbers. Product is 12, difference is 1. Okay. And I'm sure you have figured out 4 and 3, right? 4 times 3 is 12, and 4 minus 3 is 1. But that doesn't mean your factors are x plus x minus 4. Okay, now some of you might think my factors will be x minus 4 and x plus 3. That will be incorrect. Okay, because your main coefficient is 2 here, you know. You cannot directly write the factors like that if your coefficient is not 1. what instead you have to do is write it as 2x square. The numbers are 4 and 3, right? And you know this negative 4 and positive 3 because the number is minus x there. So write that negative 4x plus 3x minus 6. So that is splitting the middle term by knowing the product and the difference. Okay. Then your factoring will come into picture. 2x is a common factor in the first two terms. You get x minus 2. 3 is a factor in the next two terms. And you get again x minus 2. All right. Then you have x minus 1, x minus 2, 2x plus 3. X minus 2 is factored out now. And what remains is 2x here and 3 here. Okay. There is one more way of doing this factoring without like this, just by getting all the zeros, which I might illustrate in the next problem. Okay. And then maybe I don't know, if time permits, I'll come back and do this as well by the second method. Let me call this method 1 for now and keep it. Okay. Now, if I don't get time in this video, you will have to do that by yourself. Okay. I'm going to do method 2 for the next problem. Use factor theorem to determine. Oh, okay. We will do the factoring as well. Okay. The question itself is very simple. Just to know whether that is a factor or not. Hopefully, if it is a factor, then we will do the complete factoring. Okay. Let's check. Go ahead and do it, please. Again, you know the method by now. X plus 1. So you have to take minus 1, as your term on the left side there, the divisor, and write the coefficients in the decreasing order, which are neatly given here. And then you drop it, minus 1, 5, minus 5, minus 36, plus 36, 0. Luckily, it's a factor. Okay. Okay. This time I'm going to show you the second method of factoring. Okay. So here, let's see. Therefore, they didn't give a name to this polynomial, so I'm going to give the name. Okay, equals p of x. So I have to write less. All right. Okay, p of x equals x plus 1 times. Oh, I'm realizing, once in a while I might be speaking softly, especially if I'm working, mentally and writing. I'll try to be conscious and write, speak in a constant volume. But you can adjust the volume as well, okay, if needed. You can also hear the sound of the train that is passing nearby. It's in the morning 6:41 a.m. Okay. X plus 1 times x square plus 5x minus 36. Right? Now, I can factor that, and you can factor it directly, okay, with the method that you know. What I will do is, I will illustrate. First of all, I don't know if you can factor it. Yes, you can factor it with the method that you know, okay? But I will give you a different method, which is, look at the number 36 there. I'm illustrating this second method for this problem, but you can find it more useful for the previous problem, okay? Because the way of factoring, the method of factoring I showed there, this method one, some of you might find it difficult, right? So what I'm illustrating is method 2 here, okay? In this method, you look at the constant number, and actually this method is based on factor theorem, okay? This is an application of factor theorem. You see the number 36 there, so write the factors of 36 here. It might look intimidating because there are so many things here, but you will see that, we don't have to work with all of them. The factors of 36 are going to be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 9, plus minus 12, and plus minus 36. Think of that. We write plus minus because it could be either x plus 1 or x minus 1. And 1, 2, 3, 4, 6, 9, 12, 36, right? Those are the factors of number 36. But we don't have to do all of them, don't worry. Check with small numbers, okay? Like if just this part of the polynomial, I'll call it q of x, let's say. So if I plug in 1, q of 1, you can very easily check it's not 0. Basically, I'm going to find out when it is 0. Okay, if you plug in 1, it's going to be 1 plus 5 minus 36. That's not 0. Actually, you can very easily check 2 is also not 0. Because if you plug in 2, at the most, you are going to get 4 plus 10, right? 4 plus 10 is 14, but you are still subtracting 36. That doesn't make it 0. So what doesn't work? Plus minus 1 will not work. Plus minus 2 will not work. I can see it easily. Okay. You don't have to even write this actually, if you can mentally work it out quickly. Plus minus 3 also is not going to work, but you can verify. 3 square is 9 plus 5 times 3, 15. 9 plus 15 is 24. It's still less than 36, right? So that also doesn't work. Let me check 4. So like small numbers or sometimes big numbers, you can rule them out just by looking at the polynomial. Okay. Then look for something which is more like, near, or which looks like, will work. If I plug in 4, 4 square is 16 plus 5 times 4 is 20 minus 36. 36 minus 36 is 0, right? Bingo. Okay, we hit it. So when I plug in q equal to 4, that becomes 0. That's it. If you want to even continue further and find the other 0, then you don't have to do any work. You can directly write the factoring. Or you have realized that 4 is a factor. What you do is you go ahead and do the synthetic division with that 4. Okay. Synthetic division of what? Of q of x. And the coefficients are 1, 5, minus 36. Okay, let's do the division. And I know the remainder is going to be 0. Actually, okay, I already know that. I already know the remainder will be 0 because 4 is, q of 4 is 0. That is the remainder, right? By the remainder theorem. Okay, so this remainder here is 0. Let's do the rest of it. 1 will be dropped down. 4 times 1, 4. 5 plus 4, 9. 4 times 9, 36. Okay. Now the achievement here is not just to prove that the remainder was 0 or verify that the remainder was 0, but we also have the factor. Okay. So now I'll write my original thing. P of x was x plus 1 first, right? Then we found that q of 4 is 0. So x minus 4 is the other factor. And then the quotient you have at the end is x plus 9. Okay. So this is a second method, I would call it, method 2 of factoring. Between method 1 and method 2, whichever you find convenient, and for different problems, like this or that, one of the methods will be more suitable. Or as you are doing it, you can, if you can already see how to factor it, go ahead and factor. That is method 1. If you are stuck about factoring, you're not able to figure out the factors by thinking of the sum and difference, or the product and difference, then you can go for method 2, in which you have to look at the constant number, look at the factors of the constant number, and as I said, you don't have to keep plugging in everything and check. Use common sense and just don't you plug in some of them, because you can see that it's not going to be zero. Either it is too small or too big. And when you start to figure out something getting smaller, then you know that it might become zero around that, right? So in this case, we found that q of 4 is 0. That means x minus 4 is a factor. If q of minus 4 gives you 0, then x plus 4 is a factor. Okay. And once you know that, what you do the synthetic division with that 0, with that 4 here, the ZDR 0. Okay, with that. And as you do the synthetic division, you'll get the end result will be 0. That will verify, double confirm that your calculation was correct. Not only that, it will give you a quotient, which will be another factor, right? And actually, with this method, you can factor even higher degrees, degree 4, degree 5. You can keep getting new factors, and keep getting new quotients, which will be smaller and smaller degrees. All right. Okay. Let's see. We are on page 12. And did we do everything that was asked of us so far? Yes. So I'm going to now page 13. Okay. I have about 7 minutes or 6 minutes. Let me see. I might be able to introduce it here and then continue it on the next page. Okay. Now, some of these concepts I have talked about before. The concept of conjugate, right? I remember in one of the videos I was telling you, if your polynomial has integer coefficients like 2, 3, minus 2, minus 3, like that, and if you get one of the two situations, either your roots are the zeros, when you solve the equation, either they are irrational numbers or they are complex numbers, then they will always occur in conjugates. Okay. So for example, if x equals 2 plus root 3 is one of the roots, then 2 minus root 3 will be the other one. Has to be. Okay. In the same way, for complex numbers, if 4 minus 5i is a root, then 4 plus 5i also will be a root of that particular polynomial. Okay. So that is what we mean by conjugate zeros theorem. If polynomial p of x has only real coefficients, now this will be true only when the coefficients are real numbers, okay? And if a plus ib is a 0, okay, then a minus ib is also a 0. All right. Now, if that is the case, we are asked to find a cubic polynomial having the given zeros. Okay, and I'll add a coefficient here, sorry, adjective, real. Real cubic polynomial means cubic polynomial with real coefficients. Okay. And the solution would be this. The third zero. okay, must be 6 minus 2i, right? The minus 3 is a real number that is not irrational either, it's a rational real number, so that can occur independently. But if 6 plus 2i is one of the zeros, then 6 minus 2i must be the other zero. And because it's a cubic polynomial, you have only 3 zeros. Okay, so those are all the zeros you have. Therefore, it's as simple as this. Okay, minus 3 is a 0, so x plus 3. And okay. I'll just call it x plus a and x plus b for now, not plus actually. Minus x minus a and x minus b for now, okay? And that a and b being this is my a and this is my b, okay? And to write the final answer in a simplified form, let me first actually obtain x minus a and x minus b. Okay, here x minus a and x minus b, right? What do you get? When you multiply them, you get x square minus bx minus ax plus ab, So when you simplify it, it becomes a minus a plus bx plus ab. Okay, so first this part. If you are like a little lost here, pause and make sure that you understand that multiplication. You can literally do the multiplication one by one and verify. Okay, I'll just read it out. X square, x times x square, then it will be minus bx minus ax plus minus a times minus b will become plus ab, right? Both are minus, so you will get plus ab at the end. What that means is, if you get a plus b and ab, then you can write the polynomial. So this is a better way of doing it, okay? So a plus b here will be 6 plus 2i plus 6 minus 2i, right? The 2i and 2i will cancel, you get 12. And AB will be 6 plus 2i times 6 minus 2i. And in the previous, one of the previous videos we have studied, when you multiply conjugates like that, it becomes a square plus b square. That is 36 plus 4, 40. Okay. So your polynomial p of x, therefore, is x plus 3 at the front. Then the rest of it is x squared minus a plus b is 12x plus ab is 40. Okay, that second part, x minus a, x minus b, I multiplied it as x square minus a plus bx plus ab here. And then I found the value of a plus b and ab and I plugged in here. Okay, I'll see you in the next video. Thank you.